Hello, this is our first lesson of Mechanics Year 1 of the Cambridge International AS level. And we're going to be heading through velocity and acceleration first. Now, when you're dealing with velocity and acceleration, you need to understand some certain things. So velocity is a lot like speed, except velocity is speed in a particular direction. So for example, if you were heading at 80 kilometers per hour east, then that's fine, okay, and that could be a speed, and that's fine. But then if you were saying what would that velocity be in terms of, whether you were heading west, then it might be negative. Okay, so you need to watch out for velocity because velocity is a lot like speed, except it can be negative and it does reference direction. Similarly, displacement is a lot like distance. However, displacement again is all about whether it is in a particular direction. So, for example, you could have something that is 60 meters east. Okay, well that would be negative 60 meters west. Okay, so you can have negatives involved. Now, an important formula that you need to write down is that an object moving with constant velocity u units. Now, velocity, your initial velocity will be u as its notation. Okay. Now, when you get later on throughout the course, you will have u as being a starting velocity, and then following some acceleration, there'll be a higher velocity. So, for example, you might start going at 10 meters per second, and you're going downhill. So, after a while, you're going 20 meters per second, and you would have a u and you would have a v. Okay, and that might be determined by some level of acceleration. The constant velocity u units in a particular direction for a time t units makes a displacement s units in that direction. Okay, so if we're heading at a velocity of 20 meters per second in the direction of the east, okay, then the displacement in the direction of the east would be positive as well. Okay, we tend to need to use meters and seconds in mechanics. All right, so here's part one of example one. So it says an airliner flies from Cairo to Harare, a displacement of 5,340 kilometers south at a speed of 800 kilometers per hour. How long does that flight last? Okay, now this is a lot like your distance, speed, time, but we know that you've got S equals UT. So the formula that we like to use and we like to manipulate in mechanics for this would be S equals UT. Now, how long does the flight last? That's clearly a t. Okay, a speed, well, that's actually u. Don't get tempted to think S is for speed. S is for displacement. Okay, so this will be our displacement. And what a good idea is to try to pop in. We've got 5,340 kilometers. Okay, at a speed of 800 kilometers per hour multiplied by time in hours in this case. Okay, so this question hasn't quite got to the point where we need to be able to use meters per second, but it does have kilometers per hour, kilometers, and so we know that the time will be t hours. And we can manipulate that, so we can say, well, I've got those things. It's a good idea to put your units in there. I don't see any reason why not. Some people like to manipulate the equation first. However, I think that that's probably not necessary all of the time. And so we're going to do 5,340 divided by 800. Okay, now 5,340 divided by 800 would be 6.675 hours. Okay, so 6.675 hours. Okay, now what it's not asked us to do is to give that in particular minutes and seconds or anything like that. Okay, you might be asked to do those things, and you should be able to do that from GCSE. In general, this is a mathematical model, and as you could imagine, that plane cannot continually go at 800 kilometers per hour because it has to take off, it has to land, it might go a little bit quicker or a little bit slower depending on some turbulence or something like that. And so therefore we'd probably say roughly 7 hours, okay, might be an answer that would be accepted as well. All right, but we've got 6.675 for that one. We don't need to do much more with it. All right, next up, we've got express a speed of 144 kilometers per hour in meters per second. Now, for this, there are lots of like tricks and tips and things like that. But for me, I tend to just write 144 kilometers equals 1 hour and then sort of work from there. Okay, so I want it to be in meters. So I'll multiply by 1,000 over here. So that would be 1,000, that'd be 144,000, pardon me, meters in 1 hour. And then we need to find out what that would be in seconds. Now, there are 3,600 seconds in an hour because it's 60 in a minute, 60 minutes in an hour. So we're going to go with 144,000 divided by 3,600 to find out how many meters per second we have. So 144,000 divided by 3,600, and that comes out as being 40 meters per second. Okay, so 40 meters per second. Look here, ms to the negative 1. You know that s to the negative 1 is 1 over s. Okay, so this would be equal to m over s, which is meters per second. Okay, really often it's written as ms to the negative 1. It means meters per second. It's read as meters per second. It's not very often read as ms to the negative 1. Okay. The next thing we need to be able to work with is grasp the constant velocity. Now, constant velocity means that we're heading at a particular speed and we're doing that consistently. We're not slowing down, which is fine. But you need to remember with vehicles and things like that, they do speed up or slow down from their starting point. Okay. Now, displacement time graphs are a common way of showing problems. When we have a constant velocity, we'll have a straight line with displacement u. Okay. Now, remember our formula was s equals ut. Okay, so we have s equals ut. And if we think about this as being like an x-axis and this as being a y-axis, this would be a lot like y equals ux. Okay, and so u would be the gradient, okay, provided we've got a consistent straight line. Okay, so u is the gradient when we've got a consistent velocity, and we'll have a straight line when we have that consistent velocity as well. Velocity time graphs can also show displacement. So in this case, obviously, we would have velocity time graphs. So you'd have, we know that s equals ut, so we've got across u and up, across t and up u. Remember, time should always be a horizontal axis no matter what. So you've got time, velocity. Again, it makes sense that you have ut multiplies to make s. Okay. Let's take a look at that. So an aircraft flies due east 800 kilometers per hour from Kingston to Antigua, a displacement of about 1,600 kilometers. Model the flight by drawing a displacement time graph. Okay, so we've got a displacement time graph first. Now, 800 kilometers per hour, and we're doing 1,600 kilometers. Okay, that should mean that we've got a time of 2 hours in hours. Okay, to get to a displacement of 1,600 kilometers. Okay, and so we'll get to there and we'll have a consistent velocity happening as well. Okay, so we'll have that there. All right, label your graphs to show the numbers 800 and 600 to indicate the units used. So 800 and 1,600 to indicate the units used. So we've got 1,600, we've got 800 km. Okay, would be with the 1 hour there. Okay, and so we've got those bits and pieces there. All right, next it says a velocity time graph. Okay, so it's all about velocity over time. Take a look again. The velocity time graph, if you've got consistent velocity, should be this rectangular sort of shape here. Okay, so over a certain amount of time, we should be able to plot that fairly easily. So we know that the duration of the flight would be 2 hours. Okay, we know that s equals ut. We know that the displacement is 1,600, and we've got a velocity of 800 kilometers per hour, okay, which is times 2. Okay, so we should have up here 800, so that we end up with 800 times by 2, okay, kilometers. And that would be our line there, okay, and in here would be our 1,600 kilometers total displacement. Okay, so s equals 1,600 kilometers. All right, could you suggest ways in which your models could be improved to describe the actual flight more accurately? Yeah, things like it might not start off as quick as it should do, so you've got to take off and you can't automatically do that at 800 kilometers per hour. And likewise with landing and things like turbulence and stuff like that. The velocity will be variable in this case, and so it shouldn't be taken as being a constant unless you've got a really simplified model, which is what we've got. Okay, so your task, you can see a picture of the course book, which you should have if you're doing this course. complete the course book exercise 1A. Okay, good luck.